Throughout human history, we've built an incredible body of knowledge about the universe around us. However, we're only at the beginning of this journey. The universe is a twilight zone of secrets, unexplained mysteries, and black holes, shaped by unseen forces. In this video, we will reveal some of them. What lies beyond the universe? Does Planet 9 really exist? Is there life on Jupiter's moon? What did Voyagers 1 and 2 detect beyond our solar system? It is generally considered that the universe has no bounds, no beginning, no end. Perhaps after today, you'll no longer consider our universe synonymous with infinity. After all, what has a beginning, sooner or later, will find its end. The infinite nature of the universe suggests that it must be infinite, not only in terms of space, but also in terms of time, which means it would contain an infinite number of stars. If that were the case, our sky would be densely populated with stars and incredibly bright at all times of the day. However, the darkness of the night sky suggests that the timeline of the existing cosmos is not infinite. And so, according to this theory, the universe was created as a result of a powerful explosion from a point of densely packed matter and energy, also known as singularity. Mark a sheet of paper with a stop. This presence would result in expansion. Just as the paper in your hands is trying to take its previous form, the universe expanded, albeit on an entirely different scale. And everything in the universe, past, present, and future, is the consequence of that event. Everything we see and feel, the matter that we're composed of, everything formed thanks to that process. So how was everything we see around us born from such a destructive process? At the beginning, a millionth of a second, almost instantly, spread the extremely high temperature substance, the plasma. From that emerged the elements that make up our world today, such as protons, neutrons, electrons. This process is known as baryogenesis or baryosynthesis. It led to conditions that made it possible for hydrogen and helium to form, which subsequently formed the stars. The life cycle of a star will form everything that our world is made of. First, let's talk about how we were able to have a glance all the way back to the start of the universe. Then we can discuss why it is so difficult to find its edge. To travel to the life cycle of a star will form everything that our world is made of. First, let's talk about how we were able to have a glance all the way back to the start of the universe. Then we can discuss why it is so difficult to find its edge. To travel to the radiation of the universe, also known as cosmic microwave background or CMB. In the 70s, the process of space exploration resulted in the discovery of a number of zones we could not see properly. Some of the images looked as if there was a lens flare. The strange thing was that all the cosmic sources of light known at the time, such as the dying or emerging stars, were too far from these flares. They couldn't have been the reason for this phenomenon. This is how the scientists learned about relic radiation, and what you're seeing on the screen is the effect of this radiation. This white noise is the real echo and voice of the early universe. When scientists set out to research this phenomenon, it became apparent that the radiation occurred at the very moment when the universe was first lit up by the emergence of chemical elements. We learned that this radiation is not related to the stars or other sources of light thanks to the WMAP probe. Thanks to WMAP, we were able to receive the first comprehensive map of relic radiation in the universe. More detail was added to the map thanks to the work of the Planck Space Observatory. Take a look at it. Doesn't it look like the previous TV image, but in color? This echo of the Big Bang is dispersed across the universe incredibly even. This is the light of the birth of our universe that's existed since the Big Bang. And thanks to this light, we're now able to see the true structure of the universe and realize the universe is finite. The things we are able to see or calculate using a computer model was called the observable universe, and the things that we can explore within it are known as the meta-galaxy. So where are we within this system? Let's have a look. There's our home planet Earth and the solar system. The solar system is a part of the local stellar system. Along with the neighboring stars and their systems, we are part of the Milky Way galaxy. The galaxy itself is part of a larger group of galaxies. As we zoom out even further, we can see our place among other galaxies in the Laniakea supercluster. Seems huge, doesn't it? The final reference for scale will be the observable universe. In the grand scheme of things, we are only a tiny grain of sand. But even an entity of this size has its limits. We're facing the fundamental question. Everything that we see, is that the extent of the universe? How can we see beyond the light emitted by stars? Take a closer look at the map of the cosmic microwave background. The brighter spots signal the changes in temperature in space, which signifies where the star systems, galaxies, and supergalaxies can be found outside of our visual range. Is it possible to use relic radiation to see the entire universe? Think about the night sky. If you're on a brightly lit street or next to another source of light, such as a campfire, it's difficult to make out the faraway stars in the sky. Same principle applies here. Relic radiation illuminates the universe in all its glory. However, its light also hides the dark alleys of the universe. For example, the areas devoid of stars. It also hides black holes and places in our universe that have not yet been reached by light. Remember, the consequences of the Big Bang are still relevant. So is there anything beyond this edge? It seems that the answer to this question was found through the inflation theory. According to this theory, the bounds of our universe continue to expand at a rapid exponential pace, which leads to a conclusion that the universe cannot have a concrete boundary. Let's circle physics dictates that the inflation theory has its issues, because the laws of physics work in the same manner in every part of our universe. Even though scientists found countless things that confirm the rapid expansion of the universe after the Big Bang, as well as plenty of facts that suggest continuing expansion, that's far from being the big picture. For example, observations showed that galaxies and stars have an ever-increasing speed as they move apart from each other. Seemingly, this would confirm the inflation theory of the universe. Nevertheless, questions remain. What was happening when the universe did not yet exist? If the universe emerged from singularity, does that mean that there was a time before this singularity existed? If the same laws in the universe now, as well as things that happened before and things that will likely happen in the future. The theory, the beginning of the 20th century. The Friedman-Robertson-Walker model suggested that since the universe has been expanding since the Big Bang, it is only logical that at some point it compresses back into a singularity. According to the theory, however, soon their theory was revealed to have a serious contradiction because the concept of entropy had been discovered in the 1930s, which is the process of endless dissipation of energy through space and its decay. Entropy would mean that each cycle of the universe would require more and more energy. Friedman and his colleagues could not get an answer as to where this energy comes from initially.